So, for the last recording that we're going to be having for Halloween week, I figured that dressing up as death wouldn't be a terrible idea. Because I know some of you look at this as though it's a fate worse than death, and figured that I might as well dress the part. So, with that being said, let us begin what we shall be doing with the second day of 2-3, which is composition of functions with a little bit more algebra to do than maybe we've done in the past. So here's what we're going to be doing for this. Essentially, what you're doing in the process here is you're going to be looking at taking two functions and creating a brand new equation. Now, you'll notice with both of these, if we want to create a new rule, what it means we have to do is take the functions themselves and combine them with x, not with an input, so that we can create a rule that can be used once they're combined. So with that being said, what you're going to do is the same process as to what we did before, but it's going to look just a little bit different. So right now, we're going to be using the g of x and the f of x. And these are the two functions that we have up here. Now, I'm going to try to do this a little bit differently. So what I'm going to do here is to say, all right, let's take our g of x. We're going to make this, that is sort of our blue color that we have here. So what that means here is that the actual thing I'm going to be using on the inside of this set of parentheses is not a number that I get when I plug something in, but in fact, the whole expression, 5x plus 4. So what I'm going to do is I'm going to go in here and instead of g of x, I'm going to write 5x plus 4. Now, these parentheses that are on the outside of it are the ones that come from the outside function, that f. So what we're going to do is we're going to write that on the outside here, f of 5x plus 4. Now, anytime that you have something inside the parentheses of a function, that is what we replace our variable with. So in this case, the function is 3x minus 2. We've done in the past, when we put a number in there, is we take this expression, we write it. Wherever there's an x, we replace that with a set of parentheses. And we're going to do that here. It's just that our set of parentheses is going to have to be a little bit larger. So it's 3x minus 2. We write here, 3 parentheses minus 2. And in that set of parentheses there, we take whatever is on the inside of the input variable. And so here, because we're plugging an entire equation in, that means that right here, we're going to have 5x plus 4. The entirety of that equation is going to be in here. Because what we're going to do is simplify this and now get a new equation to represent all of what we need. So that's what the work is going to be now. I've got a 3 outside of parentheses, so I'm going to distribute that to both things here. 3 times 5x is 15x, plus 3 times 4 is 12, and then a minus 2 here. We combine our like terms, that 12 minus 2, and that is going to give us a total of 10. So at the end of this, our combined function is going to be 15x minus 10 when we do f of g of x. So that means if I wanted to plug something into this, f of g of x, if I plug it directly into this rule, I don't have to take it through both equations because this is the combined equation for both of them. To do it in the other direction, it's literally exactly the same thing. We take it with the f of x, and we go in the opposite direction. So I'm going to use f of x on the inside. So that'll be a 3x minus 2 right here. And I'm still going to have the big old parentheses around the outside here. So I'm going to have this here. There's going to be a g right there. And so this is what I'm going to be plugging in. And again, our function here for g is 5x plus 4. So you write that equation, 5 big parentheses instead of my x, plus 4. And in here is going to be what we had for the f of x. So that 3x minus 2 is what is going to go right in that set of parentheses. And now we combine this. So here, I'm going to do distribution just like I did before. This will be 15x minus 10. Still have that plus 4 right here, so we're going to bring that down. And then we've got to combine our like terms. So negative 10 plus 4 will give us a negative 6 as a final result for that. And we'll have 15x still left here. We can't combine the two of those because they're not like terms. So at the end of this, we know that g of f of x is equal to 15x minus 6. Two different ways of looking at it, but it is what we can use to be able to come up with what we're going to get as our answer. Now, I will say, when you're looking at something like this, in these cases, we didn't get the same answer. And most of the time you won't. There's a special relationship we're going to learn about later in the chapter that deals with what happens when we combine these and they give you the same answer. And in the case of this, it didn't happen, so we're not going to have to worry about that. So let's save that as sort of a thing for later as we're going to look through it. Now, it's interestingly asking for what do we do when we have f of g of x with these different rules. This is sort of our last part. We've got a multiple choice here, which is fine, but sometimes they're harder to deal with. We're still going to have to do the work and get to it, even though I could say, oh, it's 3 or oh, it's 2. But this is something I've got to do. So again, we're starting from the inside, g of x. That is that x minus 5. So I'm going to rewrite this, the x minus 5 here. There will be the parentheses around the outside of it. And we're going to be doing the f. So f of x minus 5. Now f of x is x squared. So that's going to be parentheses squared. And inside this parentheses, it's going to be x minus 5. Now, I like this. The rule we're actually trying to get you to work with is how do you plug one function into another and create a new equation. What I like about this is it gives us an opportunity to review the idea of what happens when you are squaring a binomial. Now here, I'm not just going to do x squared and 25. That can't be right because when I do this, I've got 2 terms. And what that means we're going to have to do is bust out a Bechtel box on this bad boy because there's 2 of them here. That means this will be x minus 5 times x minus 5. 2 of them means I'm going to have to make a 2 by 2 square here when I'm multiplying these out. And on the outside of this, I'll have x minus 5 on this side, and I'll have x minus 5 on this side. So when I multiply these answers, what I'm going to be getting inside of these 4 things are the terms that I'm going to get when I do this multiplication. So x times x is going to be x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, and negative 5 times negative 5 is positive 25. Now, what we'll notice is that the only like terms we have here are the ones that are on the diagonal, as is often the case when we're going to be doing things where we're multiplying 2 binomials together. And so that means that when I combine these for my final answer, x squared is its own term. So I just write that down, x squared. Negative 5x and negative 5x, since they're both negative, they're going to be more negative. We add the numbers together and get negative 10x. And that 25 is on its own, so that'll be plus 25. And what you'll notice is that that is the same as this result we have here for problem number 4. So f of g of x is going to be x squared minus 10x plus 25. And that gives us our final result for what we're going to be having here. That's all you're going to be needing for this. And so that's a place for me to say you have all of the notes that you need for page 8, the second part of 2-3. And I will wish you guys a happy Halloween.